Okay, let's get back to uh, probability. Okay, now let us see one more example. The example, let us, I have a sample space for an experiment, which is a coin is tossed three times. So let us write the sample space for the experiment which is done uh, for a coin which is tossed for three times. So coin has got three faces in it. So head and tail. Okay. So three times it is 2 cube. So it should be 2 cube. So there is 2 cube. That is eight such type of possibilities. That is head and head, head and tail, and so on. Tail, tail. Right? So these are totally eight. So this is considered as a sample space. So uh, how did we arrive to this solution? Now, if a coin has been tossed, one thing, and it is a single coin, okay, a coin. That's why it's a single, which has got two faces, that is head and tail, okay, and three times. So it should be to the power of n, which is three. So you get eight such possibility. Okay, I hope you understood this. Any queries? Okay. Okay. Let me explain once again. How do we arrive at this solution? Now, head and tail. A coin has tossed. If a coin has been tossed three times, so it is 2 cube. So n will be 3 because 3 times. So that's why. And the maximum possibilities of getting. So yeah, this is one coin, this is another, and this is another coin. So getting that one, again another, and another, and so on. So it is 2 cube, which is 8. So I hope you understood this. Okay. Okay. Then let me move on to next problem. Yeah. No, see, this is there is another way, but since the sample size is very small, that is 2 cube, so I don't need some other method. So when the time comes, I'll try to explain that. Okay. So let's see next problem. Now describe the sample space for the indicated experiment, which is a dice which is thrown two times. Okay, a die which has got six faces in it: one, two, three, four, five, and six. Okay, now what will be the sample space? So, which is thrown twice. So it should be 6 square, which is 36 times. So we have 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, and 1 comma 6. Okay, like that you have 2 comma 1, 2 comma 6. Likewise, 6 comma 1 and 6 comma 6. So these are the possibilities which you have. So this is entire a sample space. So I hope this is like previous problem which we have coin tossed thrice and so on. So there is eight such possibility. Here it is 36 such possibility sample space. Okay, fine. Let us move on to next problem. Okay. Now describe the sample space of getting 4 times. So 4 times. So it is 2 to the power of 4. So this becomes 16 times. Okay. Again, head, head, and head, 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 and head, and tail, tail, tail. So this will be 16 times. Okay. So 2 to the power of 4. Okay. So that's that. Now let us try to understand next problem. Okay. Any queries? All right. Because it's the same thing which are done in the first problem and second problem. Okay. So I don't think so. If you're having any queries. Okay. Now let us see the next problem. Now let us try to understand this problem. Two boys and two girls are in a room X. Suppose this is the problem. Two boys, two boys, okay, and which I B represents boy, and two girls, okay, in certain room, okay, and that is represented as X. Room has been labeled as X, and one boy and three girl in room Y. One boy and three girl. Okay. Again in room Y. Specify the sample space for the experiment in which a room is selected and then a person. Okay. You're able to understand this problem, right? Okay. Uh, so I'll represent the boy one and boy two and girl one and girl two. Okay, representation, so that we'll not have any problem with that. Okay, specify the sample space for the experiment in which a room is selected and then a person. A room is selected and then a person. Okay. Now how is this possible? Let us see that. So a boy, I'll represent this, and again with respect to this, y is boy 3 and this is girl 3, girl 4 and girl 6, girl 5. Okay, so you have that. So according to that, we have, uh, let us denote one boy and three girls. Okay, we'll take that y, okay, as one boy and three girl, and like that. According to that, sample space is given by the x is v2, comma x being with respect to, again, uh, the v3. Okay, now again this x with respect to g2, okay, and x with respect to g1. Fine. G1, yes, and y with respect to b 3, okay, and y with respect to g3, as well as y with respect to g3 and y with g4. Okay, that's done. So we have selected all those. This is b1, okay, b1, and this is b2. Okay, so that's the sample space which we get. So what is it? 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 space. Yes, I already said in the previous problem, or again, the sample space is that when you have the total number of possibilities. So if previous problem which I have discussed, 2q, which is 8. So 8 we got as H and tail and so on. So tail and tail and so on. So this is a sample space. So this corresponding to the problem, this is a sample space. So here this is a sample space. Okay. I hope you understood this. Okay. Now let us see any queries. Any, okay. Fine. I hope everybody understood this. Okay. Now let us see one more problem. No queries. Yes. Okay. A box contains one red. A box. A box contains one red and three identical white balls. Okay. Two balls are at random, drawn at random in succession without replacement. Okay. Uh, Let us write the sample space for this experiment. Okay, without replacement. Okay, that is very important. uh, Now a box containing one red and three white. uh, Let us and you see this box contains a total number of balls which is 4. Okay, so 3 plus 1 which is 4. So the the one without replacement should be red white. Okay, this is one, and white red. Okay, and white and white. So these are the possibilities. Okay, so without replacement. Okay, so do you have any query? Okay, yes, some other examples. Yeah, as in when we try to solve, uh, yes, I'll provide you another example. Okay, we'll see that an experiment consists of tossing a coin, okay, and then throwing it second time. If if a head occurs, if a tail occurs on the first toss, okay, on the first toss, then a die is rolled once. Let us find the sample space. Okay, again here, tossing a coin. So tossing a coin, a coin consists of head and tail. Okay, has got two faces, so head and tail. A die has got six faces. Okay, a die has got six faces. Yes, six faces. And what I'm supposed to do is, an experiment consists of tossing a coin and throwing it on the second time, and it head occurs. Okay, so that is the problem. So you have a sample space which is S, getting head and head. Okay, head and tail. Fine, and one at a time, tail, and with respect to that is a first toss. Okay, which if tail occurs, okay, I have kept tail, and the rest is this. Five. Did you understand this? First sample space, only a fair coin is considered. Okay, so I have two such possibilities: head, and head and tail. Okay, there's only two possibilities you have with it. And second part of the problem, which is as you are keeping one as tail, a coin has been used, and the rest, a die is rolled once. So once becomes uh, one, and tail with respect to two, tail with respect to three, four, five, and six. Did you understand this? Any doubts? Okay, okay. Uh, Thank you, thank you. Yes, that's fine. Did you understand this? This is very important. This problem is entirely different, which I have been doing in the previous whole lot of problems which I have done. Any queries? You can ask now. Okay, fine, fine. Thank you. Let us look into next problem. Okay. Suppose three bulbs are selected at random from a lot. Okay. Each bulb is tested and classified as defective. Defective, which we always represented as D, and non-defective is represented as N. Okay. Uh, Let us write the sample space for the given experiment. Okay, three bulbs are selected. Okay, so whatever may be the possibilities: defective, non-defective, defective, and defective again. So let us write that. Okay, so the those sample space. Okay, and it should be of three bulbs. Okay, so defective, defective, and defective. Okay, defective, non-defective, and defective. This can be possible, and defective, non-defective, and non-defective, and we have non-defective, defective. Fine, that's that, and non-defective and non-defective, defective. So and again non, and defective, and again and. So any doubts in this problem? Fine, fine. I hope you understood this. Fine. Okay. Okay. Let us move on to next problem. Okay. The coin is tossed. Okay. If the outcome is head, if the outcome is head, a die is thrown. If the die shows up an even number, an even number, the die is thrown again. What is the sample space for this experiment? Let us see this. How to solve this problem. Okay. First, let us look at the first phase. A coin is tossed, right? The possible outcomes: head and tail. Okay, that's that. And a die is thrown. The possible outcomes will be one, two, three, four, five. It's done. Now, uh, what will be the sample space experiment done on this? That is, if the outcome is head, okay, a die is thrown. If the die is shown up an even number, okay, and a die is thrown again. So that's that. So we have the total number of sample space, keeping head or tail. First is if the outcome is head and die is thrown. So that is first is keep it as tail. Okay. Now head. 1, head 3, head 5. Fine. And the possibility of getting even number and when a die is thrown. So that is head 2, 1, head 2, 2, head 2, 3. Okay. Head 2, 4. Fine. Head 2, 5. Head 2, 6. Fine. Head, tell me. Head 4, 1. Head 4, 2. 4, 3. Fine. So 4, 4. 4, 5. Fine. 4, 6. Fine. 4, 6. And we have 6, 1, 6, 2, 6, 3. We have 6, 4, 6, 5, 6, 6. Do you understand this problem? Any doubts? Okay. So, so let us see, and we'll try to continue in the next part of the problem. Okay. Thank you.